Mode of a continuous random variable is what we are going to cover today, but please don't forget to subscribe to the channel. Now, if we have mode is a value, in simple terms, mode is a value of x where our probability distribution function attains a maximum value. So that value of x is our mode. So, mode is a value of x that gives a maximum value of f of x, i.e. it's the value of x with the maximum probability on the interval of this. If x is the mode, then for f of x means that the derivative and substitute that function should be 0. And when we differentiate this the second time, that function the second time, and substituting the value of x means that it should be negative. Less than 0 means it's negative. So where this is the mode and this is the mode also. If xi is the mode of f of x with which is continuous on interval, which is continuous on this interval a to b, then this mode is in that interval. Let us see some examples here. A PDF of a continuous variable is given by this 0 elsewhere. Find the mode. To get the mode, now we differentiate this function and we get that value of x. First of all, our f of x is going to be, if I expand that, I have x, then minus, when I open this, I get x cubed over 16, if you multiply it there. So now, get the first derivative so that I can get the value of x. And if this I get 1, and if this I get 3x squared over 16. But you say, our f prime of x is 0. So when I get now this to 0, I'm going to be adding 1 minus 3x squared over 16 equal to 0. And from there is that my x squared will be 16 over 3. And so my x will be plus or minus square root of 16 over 3. And so the values here I'm getting are so I'm getting the positive 2.3094 and then the negative is negative 2.3094. Why? Because whenever I get a square root, we expect two values. Now, to pick one which is going to, don't predict from here. We always use the second derivative test because in pure mathematics we say the value of x which is given us a negative in the second derivative is what is going to give us the maximum. So come and get the second derivative of this function here. So our f prime of x was 1 minus 3x squared over 16. So if I get my second derivative, this will be negative 6x over 16. Now you see that when I put in now a 2.3094, this one is going to give me a negative if I substitute here, which is going to be less than 0. When I put in a negative 2.3094, it's going to be greater than 0. In simple terms, it's going to be positive. Because this negative, we multiply this negative to give us a positive. But we say the value to gives us this second derivative as 0 is what will be our mode. So therefore, our x is going to be 2.3094, as simple as that. Or else, use the second derivative test to check which value is going to be the mode. When I come to this, the PDF of random variable x is given by, now we have this 0a, so we have to find the mode. So we first expand. When I expand that, my f of x is going to be negative x over 2, then minus, now it's going to be plus x cubed over 2. So can you differentiate it? When I differentiate, I get negative a half plus 3x squared over 2. But we say to get the value of x, we grade this to 0. Why? To get the value of x at maximum, or is the first derivative is 0. So meaning I will have 3 x squared equal to a half. When I take this side, when I equate to 0 over 2. So mean that now my x squared is 1 over 3 and our x is plus or minus square root of a third. So we have either x is positive 1 over root 3 or our x is negative 1 over root 3. Because the square root of this is this. Now use the second derivative test to know which value is going to be our mod. So my first derivative was x squared. So to get the second derivative, when I differentiate this the second time, this is the constant to go to 0. And you see this, and we add in 3x. So now we test using all of them. When I put in root 3, 1 over root 3 will give me 3 over root 3. And see that this one is positive, greater than 0. When I put in a negative 1 over root 3, it will give me negative 3 over root 3, which is, this one will mean it's positive, and this one will mean negative. And so we say the value of x, so our mod, so this one is our mod, would be negative 1 over 3 over root 3. But is that negative 1 over root 3, this root 3 is not in this interval, is not in the interval of 0 to 2. It's not in that interval. So that this value would have been the mod, but you see it's not in this interval. Therefore, the mod you have got doesn't exist on that interval. So therefore, just call it therefore no mod. Simple as that. So that's it, members. I wish you well.